Hello again. My name's Tomctutor, that's me. We're doing part 3 of the vector equation of a line in 3D. Vector equation of a straight line. No such thing as a straight line, just a line. Anyway, okay. In this part of the first part of these vector straight line equations videos, I showed how we set up the radial vector xyz as a point transverse as a line. This vector 3D space, the components 1, 1, 0 in this case, this red one, is the vector equation of a line through the point 1, 1, 0. So that's a fixed point. This lambda is a free parameter, can be any real value. If lambda changes, we run down, we run along the line 3D space. This vector here is the direction of the line 1, called the direction vector, and that was offset. I showed you all that in video 1. Video 2, we showed that we could have two different vector equations but represent the same straight line. So the vector, there's not a unique equation to a straight line. That's the problem. So when you're looking at that equation, it's not too clear what the line is, basically. You have to work it out. So here we have two lines, a green line L2 and this red line L1, and the problem now is to determine do the lines intersect. That's the question. Okay, so they're two different straight lines apparently. I've set up this little XYZ three-dimensional Cartesian coordinate diagram here, and it's traditional in these diagrams to put the X and the Y like that to represent the plane of XY, and the Z to go vertically up. That's what you do with vector three-dimensional diagrams. You don't have to, and some books might change that, but that's the convention normally. So I have the red line goes through the point 1, 1, 0 and the green line goes through the point 0, 1, 0. Two different equations. So do the intersect. So how are we going to solve that problem? Well, if there is a point of intersection, call it point P. It may not be, but let's assume there is, say, there somewhere, where these lines may intersect. I should emphasize that I should have said, possibly, so to clarify this, lines can be the same straight line. Maybe shoes. Lines can be coincident, okay? That is, they are the same straight line. We say that they're coincident. So these two lines essentially are the same straight line. So they're coincident. To be coincident, they have to share a common point and they have to have the same direction vector D, okay? We showed that in video 2. The lines may not be the same straight line, but they may have the same direction. For instance, these two lines here are not coincident, but they are parallel. They have the same direction. Okay, so they have the same D, but they're not the same straight lines. So that's parallel. Of course, I'm drawing this on the board, but these actually live in three-dimensional space like that. There's a line in three-dimensional space. Okay, so easier to show it on the board, I think. So it's possible that lines might intersect at a point, which was a problem in part 2. Well, no, sorry, that's a problem in part 3. Do the intersect at some sort of point here, okay? But they're not the same straight line. So we just say they intersect somewhere, okay? Intersecting straight lines. And there's a fourth possibility is that our lines are what they don't intersect, they're not parallel and they're not coincident. And these lines just generally are in 3D space like that. Trying to depict it, they don't intersect here. And so here's, I'll give you an example here, maybe in 3 dimensions. So here's my 2 pens. So that pen's up there and that pen's down there. 2 lines that do not intersect. Okay, or just like that, and like that even, or like that. So they're called skew. Okay, they're called skew lines. Skew. Okay. So they do not share a common point, they're not parallel, and they do not intersect. So from going, I'll have to erase this here, I think, to make up some room. Okay. So if I erase that, if I may. So going back to the problem, do these particular 2 lines intersect? They will intersect if I can find 2 values of these parameters, lambda and mu, such that as I run it along here, I shall land in the point P, and if I run along the green one here, I shall land in the same point P. So let's see if we can find 2 values to do that. So if I take line 1, if I look at its x coordinate of this point P, so we assume there is a point P, okay, and its x coordinate is going to be 1 plus 2 lambda from line 1, but because it's a same point in R2, it's going to be 0 plus 1 mu from line 2. So that equation has to be satisfied for a particular lambda and for a particular mu, which we'll have to work out. Only got one equation and 2 unknowns, cannot be solved. So let's take the y coordinate now, and that's 1 plus lambda 1, or 1 plus 1 lambda, and the y coordinate here is 1 plus mu naught, or 1 plus naught mu. I had 2 equations and 2 unknowns, and now I can solve these. It's just a simultaneous pair. Obviously, here if I subtract that from that, equation 1, equation 2. If I subtract equation 2, so it's 2 minus equation 1, I am going to end up with lambda, okay? And that is equal to minus 1 plus mu, okay? So I know what mu is, it's 1 plus lambda. So this equation 1, I can just put that in there. So equation 1 now, if I substitute what mu is equal to 1 plus lambda. If I substitute that mu into equation 1, I'm going to get 1 plus 2 lambda is equal to 1 plus lambda. Well, the ones disappear from both sides, and I just end up with 2 lambda is equal to lambda. Well, what's lambda? Well, lambda can only be 0, so lambda must be equal to 0. And if I go back here, then mu must be equal to 1. Okay, so solving these 2 simultaneous equations give me lambda is equal to 0 and mu equal to 1. And you might say, bingo, we found the values at lambda and mu, but you'd be wrong. Because not only have these values of lambda and mu satisfy the x and y components, they've also got to satisfy also the z component. So we have to check the third component here is, you can use X, Y, Z. I'm using Z as the third component. If I look at my equation here, for the Z component for point P, I have 0 plus lambda 0, which is obviously 0, has to equal to Z plus 1 mu, which is just mu. But mu is 1, so I've got 0 is equal to 1, which is obviously rubbish, because 0 does not equal to 1. Therefore, these two values do not satisfy the Z component. There is no Z component that satisfies these three equations with these two values. So I found, what I've done here is I found a value where these two lines cross the XY plane. Where these two values cross, basically they don't intersect. Okay, because we cannot find a set of values that satisfy these two equations. You only have to do this once. If it fails once, that's it. The lines do not intersect. So we can say that the lines, because they don't intersect, they must be skew lines. They could be parallel, but I'm looking at these direction vectors and they're different, so they're not parallel. So the lines are skew lines. Okay, so the lines are skew. Sorry, I didn't. Yeah, so you can read it. So the lines are skew. So they don't intersect. So no, they don't. Okay, and sometimes if you create a little diagram like this, you can probably see why from the diagram. This is a point 1, 1, 0, which is the A on line 1. On line 2, it's 0, 1, 0. Both of these points lie in the XY plane because they have a 0, Z coordinate. And this line has direction 1, 0, 1, so it runs like that. And it's actually doesn't have a Y sort of direction. This line 2 is parallel with the XZ plane, this green one. And this red one has no sort of Z component, so it just lies, and that's maybe not too clear here, but it just lies in the XY plane, the red line. And well, it maybe gives you an insight as to why they don't intersect. Anyway, if we do the maths, the lines are skew. Okay, so that ends that little problem. Thank you. Bye.